Imagine an egg, still, silent, and suddenly something electric. It's not just a trick, it's a physics phenomenon in the making. You've seen the spark, but have you ever wondered what happens when electricity meets a fragile shell? What starts as a simple shock can lead to a cascade of reactions, some of which are surprisingly complex. This is the moment before the show begins, an instant of potential waiting to be unleashed. And that's just the beginning. This is the electrified egg story, and it's about to get interesting. So what exactly are we talking about? It's not just a quirky kitchen experiment. It's a fascinating interplay of electricity, biology, and energy transfer. We're looking at how an egg, a humble household item, becomes a dynamic system when subjected to an electric current. The egg isn't just a shell and yolk. It's a complex, semi-permeable membrane filled with fluids and charged particles. When you apply electricity, it disrupts the balance of charges inside, triggering a chain reaction of movement and reaction. This phenomenon isn't limited to the kitchen. It has real-world applications in fields like biophysics, energy storage, and even medical research. Understanding how electricity affects living systems is key to unlocking new technologies. So, as we dive deeper, we'll explore not just what happens when electricity meets an egg, but why it matters, and how this simple system can teach us about the fundamental forces that drive life and energy. You might think this is just a fun experiment, but the principles behind it are quietly shaping the future of energy storage and delivery. Imagine if every home had a way to harness and store electricity as efficiently as an egg can conduct a charge. The way an egg can store and release electrical energy is a microcosm of how we're trying to make power systems more responsive and sustainable. It's a tiny example of a much larger shift in how we think about energy. Even in your daily life, you're interacting with the same principles: smart grids, wireless charging, and energy-efficient devices, all of which are inspired by the same kind of dynamic energy flow you're witnessing here. This isn't just about science. It's about the invisible systems that power your world. And understanding them, even through something as simple as an egg, can make you more aware of the energy you use every day. So next time you see a charged egg, remember, this is more than a curiosity. It's a glimpse into the future of energy, and you're part of that story. Let's fast forward to the 19th century, where electricity was a new frontier. Scientists like Faraday and Tesla were unlocking the secrets of power, laying the groundwork for the world we know today. By the 1920s, electricity had become essential for cities, lighting homes and powering industries, changing the way we live and work forever. The 1980s brought personal computers and the rise of digital power, making electricity more than just a utility. It became the lifeblood of innovation. Today, we're on the brink of a new era, with renewable energy, smart grids, and electric vehicles shaping the future of power in ways we've only begun to imagine. Imagine you have a tiny egg, like a baby chicken inside. Now, imagine that egg is connected to a battery. The battery gives it a little electric spark, and that spark helps the baby chicken grow inside. The electricity isn't hurting the egg. It's like a gentle nudge that helps the baby chicken move around inside. It's a way to wake up the egg and start the process of growing. Eventually, the electricity helps the baby chicken push its way out of the egg. It's not like magic. It's like a little science experiment that helps the baby chicken get out safely. So, the electrified egg is a way to help the baby chicken grow and come out of the egg. It's like giving the egg a little help to start a new life. To begin, we place a raw egg into a glass container filled with distilled water and a pinch of salt. This setup ensures a controlled environment where the egg can safely absorb ions without any risk of bursting. The salt water acts as a conductive medium, allowing ions to flow in and out of the egg's membrane. This creates a subtle electrical gradient that will later drive the movement of charged particles inside the egg. Now, the egg begins to rotate, caught in the electromagnetic field generated by the charged plates. This rotation is not random. It's driven by the interaction between the egg's internal structure and the external electric forces. As it spins, the shell experiences uneven pressure from the field. which starts to create microscopic stress points along the egg's surface. These stress points are the first signs of structural strain. The egg's yolk, suspended in the liquid egg white, starts to shift in response to the electromagnetic forces. This movement is subtle but critical. It begins to disrupt the internal balance of the egg's components. The combination of external force and internal displacement creates a chain reaction. The egg structure, once stable, begins to deform and eventually breaks, releasing the trapped energy in a powerful burst. This is the moment of transformation. The egg, once held in place by its physical structure, is now freed by the electric forces, marking the start of its new, energetic form. Now the real trick begins. The clever twist that turns energy into motion. The egg is no longer just a passive object. It's now a dynamic system reacting to the electrical field around it. This twist is not a physical movement, but a subtle shift in the way the egg interacts with the field. The shell becomes a conductor, allowing current to flow through it in a controlled pattern. As the charge accumulates, it creates a kind of electrostatic imbalance within the egg, causing a buildup of energy that's ready to be released in a precise, powerful way. The clever twist lies in how the egg is structured. It's not just a shell, but a capacitor, storing and releasing energy in a way that mimics the natural flow of electricity in a closed system. This is the moment where science becomes spectacle, where the egg structure, combined with electricity, creates an elegant and powerful transformation of energy into motion. At the heart of this transformation lies a fascinating interplay of energy and matter, where electricity doesn't just light up the egg, it reconfigures its very structure. The electric current isn't just a random spark, it's a precise transfer of energy that alters the molecular arrangement of the egg's contents, like a silent but powerful sculptor. Even in the simplest forms, like this egg, electricity acts as both a catalyst and a conductor, guiding the emergence of life with an almost poetic precision. By studying this, we're not just watching an egg transform. We're peering into the fundamental language of energy that governs all life, from the smallest cell to the largest star. Imagine a battery, but instead of chemicals, it's made of eggs. The voltage is the yolk, the current is the egg white, and the shell is the insulation. It's a kitchen appliance made of biology, and it's about to crack open. The egg is like a tiny power plant with its own built-in circuit. The yolk is the energy source, the white is the conductor, and the shell is the barrier that keeps things contained until the right moment. When the egg cracks, it's not just about breaking. It's a release of potential. It's like a capacitor discharging, but with protein and calcium. The result is a burst of energy that can light up a room, or at least a kitchen. This isn't just about physics. It's about transformation. The egg becomes something else, something electric, something that defies the ordinary. It's science with a touch of magic, and that's why it's so fascinating. So, in the end, the electrified egg is not just an object. It's a metaphor for transformation, for energy, for the way nature turns potential into power. And if you think about it, that's the whole point of science. Before you go, if you enjoyed this, please give it a like and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.